let me just briefly introduce myself and Devin and what we're going to be talking about. We're going to be talking about AI, specifically generative AI, a little bit also about sort of machine learning operationalization in general. And really the focus is going to be on how you take generative AI applications and machine learning pipelines and operationalize those, how you use orchestration to coordinate all the steps that need to happen to produce the data, the models, and the applications for generating user value and business value in a repeatable and reliable and compliant way. My name is Stephen Hillian. I run data and AI for Astronomer. I'll talk a little bit more about this in a second, but basically Astronomer is the Airflow company, Airflow, the open source platform for workflow management and orchestration. I'm accompanied by Devin Stein from Dosu. Devin, do you want to briefly say hi?
Hey everyone. Yeah, well, I guess like Stephen mentioned, I'm Devin Stein, the founder of Dosu, which I'll get into more about what Dosu is and what we do in a bit.
Great. Okay, well, it's really great to be here, and let me talk a little bit about what Astronomer does. We're really the data delivery company. I like to think of us as sort of like the FedEx of delivering data on time and reliably. Just to give a brief introduction to the idea of orchestration and data delivery, which I don't think will be terribly new to most of the folks on this webinar, but I think everybody's familiar with the idea that data pipelines really power modern businesses. Most organizations these days will claim, generally rightfully, to be data-driven organizations, and that's all driven by pipelines of data that ultimately deliver metrics to corporate dashboards, that deliver data to applications that process data in ETL pipelines, that produce predictive models, and as we'll discuss today, enable applications of generative AI, including large language models. And this is true for every company. For Lyft, Uber, for example, you take a company like Lyft, every route, every offer, all the pricing, every interaction with their users is driven by data and models. If you think of a company like Walmart, their entire supply chain is driven, well, kind of like a supply chain for data. So the delivery of stock in time for the holidays, the delivery of merchandising strategies is all dependent on data pipelines. Think of an online gaming company like FanDuel, for example, for sports betting. They use predictive analytics to determine the odds and to make sure that they're delivering the right odds and the right end user information to guarantee that their business is running profitably and in a way that brings delight to their users. All of these companies are actually powered by Airflow. Airflow is the open standard for data pipelines. It's the central control point in the modern data stack. It's actually the most popular Apache project by some measures in history, with more than 2,500, or now even almost 3,000 contributors. This slide gets out of date week by week. I think we're now considerably north of 23 million downloads, but definitely tens of millions of downloads every month. It's become the de facto standard for managing data pipelines for the sort of data-driven companies that I just talked about. Astronomer is the commercial developer behind the Apache Airflow project. We have a global team offering 24/7 support and a cloud-hosted way to run your data pipelines with Airflow at the core. And we make a significant contribution to the open source project. 16 of 25 committers are on our staff. And we've trained tens of thousands of people to use Airflow around the world. So that's a little bit about what Astronomer does and a brief introduction to Airflow. Airflow really cut its teeth at Airbnb. They were the first ones to develop the platform before they open sourced it for managing data pipelines, typically used by data engineers. And And over time, because the sort of problems that data engineers were solving are the same problems that modeling and data science teams have to solve, it extended to ML ops, and so helped to solve really a lot of the problems that you have to deal with in ML ops. So for example, you have different ways of developing and deploying models from team to team, but with something like Airflow, you have an integrated CI/CD process, and with the Astro platform, you also have an integrated IDE. You have pluggable compute so that you can have fit-to-purpose scalable compute architectures that power your Airflow pipelines. Another challenge faced by ML teams is often really uncoordinated, non-standard approaches to development and deployment. But with Airflow being a Python native framework and extensible, that means that you can use that as the common landing point for all of your data work, from the data engineering through to the model ops, and also develop custom interfaces that map to your business and technical processes. Another challenge with both data engineering and ML ops is just the dizzying array of different technologies that you have to work with. We've all seen these sort of eye charts of technologies in the modern data stack. Airflow out of the box integrates with almost all of those. Astronomer hosts a registry free for everybody to use of pretty much every integration you could want as you manage your data pipelines. And we have a lot of reference implementations to help you get started with classics of ETL workflows, as well as AI and ML reference implementations. And then once you've developed all this and you've deployed your pipelines into production, then we have all the stuff you need for what we call day two ops. So what happens when things go wrong? What happens when you need to be audited to make sure that your models are doing the right things? What happens when you need to be able to troubleshoot a broken pipeline and see how that's dependent on upstream pipelines? How do you alert your customers when a data product is going to be late? All of that operationalization and production aspects and compliance and governance is managed through Astro's platform as really an enterprise version of what you get out of the box with the open source Airflow project. And then again, as Airflow has become more widely adopted by ML teams, at Astronomer, we've developed new integrations that are particularly relevant for the world of generative AI. So we have a lot of logos here, but you'll probably recognize some of them. Integrations to LLM services like OpenAI and Cohere, out-of-the-box ways to ingest and transform data to land in vector databases like Weaviate and Pinecone, and database with vector extensions like Postgres. Let me briefly talk about the main use cases we've seen in the generative AI world that are powered by Airflow. And I'll give at a high level a few examples, but then I'll also hand over to Devon, who will discuss one in detail as a user of the platform, who is doing some really serious work and really powering all of his business through these generative AI use cases backed by the platform, backed by Airflow. So we've seen rapid adoption of Airflow by machine learning teams who are already familiar with using Airflow for classical machine learning, for traditional ML use cases, now using it for different applications of generative AI, taking them really from prototype to production. And there are three common themes that are emerging in the technical landscape in general, but in particular in the way that Airflow is used. And that's for running simple applications of out-of-the-box foundation models, for batch inference, for offline processing of data. And then a little bit more advanced, where you want to do more advanced prompt engineering with retrieval augmented generation. And then as you actually want to refine the models on a regular basis with new data, the application of fine tuning, and especially frequent fine tuning, say on a monthly or weekly or daily basis, or even more frequently, is really where the power of an orchestration platform like Airflow comes into play. Airflow is also relevant for powering these sorts of AI pipelines because of these horizontal aspects, these general aspects of, again, making sure you know where your data comes from. How did this model produce this data? Do we trust the data? Do we make sure that we're handling copyright issues and dealing with data privacy and so on? Also certain abstractions so that you can swap out with different technologies. Models are constantly changing. There's vibrant competition for improvements in embedding, and large language models. And so being able to switch those out through convenient abstractions, switch out vector databases, switch out different libraries for processing data is a really key capability of a platform like Airflow. And then the monitoring on top of this, you need to make sure that your model predictions are good and that user feedback is remaining steady or improving, that the costs are being monitored. All of these aspects are much easier if you're running all of your AI applications on a well-orchestrated platform into which you have good visibility. Okay, so let's talk about each of these examples briefly. So batch online inference is perhaps the most straightforward. You're taking external data and you're using Airflow really to then apply an LLM service in order to do some processing of, say, text data. One of the world's most widely used digital travel platforms actually uses Astro to manage the flow of data for all of its analytics and machine learning, including several applications of generative AI. For example, this travel platform has developed a trip planning application that will recommend destination and accommodation options to millions of their travelers on the platform every single day. And that application is powered by LLMs and massive quantities of operational data to create a new interactive experience for people to start their trip planning process. So this kind of conversational AI, most often exposed to end users as chat and voice bots, has become a standard way to find early value with LLMs. That's a perhaps more advanced version that uses something like retrieval augmented generation. So let me look at that one next. So in this case, you have the ability to typically, or the requirement rather, to take in sources of data from many different endpoints, process those, chunking, for example, removing header information, taking out formatting, reducing the size in certain cases, maybe summarizing, and then vectorizing that data to put it into a vector database, and then using that to power your RAG application. That upfront processing of the data, in many cases, needs to be done very regularly as the business conditions change, as you add new user feedback, as you add new documentation, as you add new products, and so on. So having a regular flow of data that is being ingested into your vector databases is exactly the sort of thing that Airflow was intended to do. And so building these sorts of support applications does require this sort of standard ingestion process from multiple sources of typically hard-earned institutional knowledge and then transforming that. And Astronomer actually does this ourselves. We have our own application called Ask Astro. It's an LLMs-powered support application using RAG, and we've published it as open source to show, partly because we want to show how Airflow can be used and provide the sort of folks who are listening in right now with a starting point if you want to build a RAG application to develop that on Airflow. And as I said, we use that internally to handle hundreds of questions a day. Finally, fine-tuning, so the ability to take a base model and to adapt that to your data, to your business situation, to the context of your applications. And in many cases, what you will want to do is you will want to take a regular feed of that data to retrain those models, often checkpointing that and starting to improve incrementally the accuracy of that model that you're using in your application. So a call center platform, we're actually going to be discussing this in an upcoming webinar. It's a digital call center platform used by companies like JetBlue, for example, and they use Airflow and large language models for automation of incoming calls. So that helps to increase their customer sat scores, reduces their operational budgets as they can streamline the process of handling calls coming into the call center. So for their customers who are using them as their call center platform, they can take in huge numbers of customer interactions and use parallel processing in Spark, in this case, for batch inference of their fine-tuned large language model. So this is actually a combination of that batch processing with regular fine-tuning of the large language to transcribe and summarize those customer interactions. So in that case, they're using Airflow for both model tuning and for inference. Before I hand it to Devin, I want to show you just one more fun example that we ourselves have built, where we're using large language models for code generation. Another common application of large language models, of course, including probably being used by many of the developers who are listening in. And so I mentioned earlier on that for data scientists, we've developed an IDE that allows you to develop Airflow DAGs, Airflow pipelines, in a notebook style interface. And we found that in many cases, you have to import a new module that allows you to connect to Slack, for example, or to run a SQL command. And so we've developed an AI prompt that allows you to automatically integrate to different endpoints, to different applications, different services, as well as suggest code. This is a very simple example where it's using the bash command operator and then inserting some code to echo the phrase hello world. So a few examples there of how you can use Airflow for pre-processing of data, for RAG, for offline inference of data in batch for processing things like incoming support requests, as well as frequent fine-tuning, for example, used by that call center application for transcribing and summarizing their calls. And all of these things in all of these examples are more and more frequently being powered by Airflow, just as you see here with our Cloud IDE application. Now, we've learned from talking to our customers and from our own applications, there are lots of challenges to putting this into production. And let me briefly summarize what we've seen. You can run into, here's a sort of grab bag of things. We've observed rate limits and API outages when you're calling these services. As I've repeatedly said, this importance of keeping the training data up to date and using the freshest data that reflects the state of your business. After all, LLMs are most powerful when they're used against your own proprietary data, all of that hard-won institutional knowledge. So keeping that up to date and using the freshest data is really the way that you make the most of these technologies. But the technologies themselves change. The tools constantly coming into the market, new APIs, new vector databases, new models, and so on, and you want to stay up to date with those. Then the actual pipelines themselves, once you've strung all these things together and orchestrated them, are really very complex, often dependencies, the need to sense when new data is coming in, the ability for data engineering workflows to trigger model training workflows, and so on. So there's a lot of dependencies and complexity there. I've already mentioned the importance of compliance and lineage, not to mention scalability, reliability, all those day two ops types capabilities that I was talking about before, as you scale this to thousands of inputs, hundreds of data sources, dozens of applications. Airflow, in the history that it has of working with data engineers and then with traditional ML, has evolved to solve really all of these problems. The ability to have automatic retries, for example. And of course, keeping data up to date is precisely why Airflow was invented in the first place. It's tool agnostic. We have this rich library of integrations that I mentioned earlier on the registry for Astronomer, handling complex pipeline structures with things like dataset-driven dependencies, dynamic tasks for doing MapReduce style bulk applications, dynamically created in a pipeline, branching infrastructure, sensors, and so on. Technologies that are well grounded now in the Airflow platform. Observability and open lineage integration is there in the open source Airflow framework and really brought to maturity in the Astronomer platform. And again, in the Astronomer platform, you have pluggable compute and the ability to run your Airflow deployments in a reliable, battle-tested way. So we do think that we have a good answer to many of the challenges that AI teams are facing right now. I want to focus finally on this idea of keeping data up to date. It really is the critical aspect of working with large language models and with AI applications. That's the key competitive advantage that most of you have by accumulating data that reflects the state of your business and what your customers and users are talking about and asking for. and the application of LLMs to that data is really where the power lies. And at this point, I'd like to hand over to Devin to talk a little bit about how Dosu has used data to provide a really valuable service for their users. So over to you, Devin.
Great, thank you, Stephen. Let's see. Perfect. Yeah, so I guess continuing the conversation, I really want to dive into an example of Dosu. And for those of you who aren't familiar of what Dosu is, at Dosu we're building an engineering teammate to help automate all the work that engineers either don't want to do or don't have to do, so they can focus on the harder coding tasks that all engineers love, while keeping teammates and users and customers unblocked. And Dosu, as we'll get into, is heavily powered by data, and is a great example of data orchestration and LLMs in production, and how Airflow, a tool like Airflow, fits into that story. So Dosu is used both internally at enterprises, but we're really well known for our support of open source communities. Like Astronomer, open source is very close to Dosu's heart. I guess before starting Dosu, was an open source maintainer, and as an open source maintainer, you end up spending a lot of your time not actually coding, but rather supporting and helping maintain the project for your community. And it's a very time-consuming role that is all about sharing knowledge that you have about your project to your users. Dosu's only been around for about 10 months within open source, but it's been really, really well received. Dosu's installed in projects in the Apache Software Foundation, within the Jupyter ecosystem, the ML ecosystem, on thousands of repositories, and has generated thousands of responses. But more importantly, is also helped resolve thousands of issues and saved maintainers hundreds of hours, and unblocked end users on whatever project that they're working on. And when we think about what is open source, maintaining open source projects looks like, it's a lot of engineering knowledge work. Where as a maintainer, you're using code, your knowledge of code changes, and all related artifacts to help support and maintain and unblock your users. So that could be, things like helping them understand if a use case is supported. Maybe it's not clear from the documentation, or it's ambiguous, but the answer lives in code or a recent PR that describes that use case. Helping with issue triage. So I think we've all run into this thing where we've, gotten started with a project and things don't go as expected. And so helping users understand, are they using the library correctly, or is there actually a bug in the library? And then also, as Stephen was talking about before, I think something that Airflow does really, really well is it has a huge contributor base. The health of an open source project is really about the strength of its community. And so a role that maintainers play and Dosu wants to help with is empowering and encouraging contributors. And in order to do that, they need to understand what files do they need to change to add a new feature or fix a bug, look for reference PRs, understand the contribution process, because that varies from project to project. And so we want to help automate a lot of this work with Dosu and support not just maintainers, but also their communities. And this is, in doing this, maintaining software is really difficult. And it's also not only challenging for maintainers, but it's also hard from an engineering perspective for putting an LLM-based application into production. Open source projects are complex and constantly changing, and typically, users end up on GitHub to create an issue or a discussion because they've exhausted all their options. They've tried looking through the documentation, but haven't been able to find an answer. They tried looking through the code, but it's unclear, what's going on. And so an example of this is, an answer, to the same question may change between versions of open source projects or even like week to week. You can say someone is running into an issue one week and the answer is that that is actually a bug in the library. The next week, the answer is actually that no, that was fixed in the last release. Engineering software and engineering systems are constantly changing, and we need to account for that at Dosu. And then also, like, documentation can be stale and misleading. I think another reason people typically end up on GitHub issues is because they're following some getting started guide and it doesn't go as expected because maybe it's stale. And so how do we, reconcile that, documentation might not be correct, and but the answer could live in code or other data sources. And similarly, like, maintainers are have a ton of context, not just about what's going on in GitHub within like code changes, but also conversations happening in Slack, Discord, Stack Overflow, or sometimes issues depend on other open source projects. So it might not even be an issue with the library, but one of your dependencies. And also, information is very unstructured and hard to navigate, which is part of the reason people rely on maintainers, is they're able to help synthesize all this disparate information in ways that helps unblock users. And then classic with LLMs is like a very important and like hard problem is correctness and evaluation. How do we know that an issue was resolved, and what was the resolution if it exists? And then also, like, are Dosu's answers correct, and how do we evaluate its responses? So this is both kind of what we are doing at Dosu and all the challenges that we need to solve. And I want to get into an example of what this actually looks like in production. I want to go through an example of Dosu on Astronomer Cosmos, which is a great example of things. Cosmos is a great example of a project that helps people get started really quickly with DBT. It's like a nice integration between DBT and Airflow. And if you can see my screen, here's an example of a classic GitHub issue where someone is trying to use this DBT task group class, and there isn't, the behavior isn't what they expect. And so they create this issue, and Dosu goes in and responds, within minutes of this issue to look across not just code, so it's able to pull relevant code files. So here's like the definition for that task group, as well as related issues that previously people have brought up about this same type of class. And it's able to combine this information and actually suggest how to fix this issue. And in this case, it gives like a very specific, here is the function that you'll need to change, and then comments like this is where you would change it. And what's really cool, and this is like, kind of like what we, something that we really want with Dosu, is that, the user actually saw this and then went to create a PR. And if you go look at the PR, it has pretty much Dosu's exact suggestion in code, and then with tests as well. So, Dosu was not only able to help unblock this user, but actually get them to contribute and grow the contribution base for the Cosmos project. And this is kind of an interesting thing where, how do we know that answer here was correct? The user actually didn't give feedback to Dosu, but the feedback was implicit in that there was a PR that was created to fix this, and that PR made a modification very similar to the one that Dosu suggested. Then I want to walk through a few other examples. Here is just a similar type of thing where someone is trying to understand how the library works. And again, Dosu is able to kind of respond. In this case, like really explain what's going on based off the actual code itself. So they're trying to understand, like, how does Cosmos replicate the functionality of DBT builds, that information actually lives in the operator itself. And so Dosu is able to explain that, and then the user closes this issue. Again, another example of like getting user feedback. There is no direct, this resolved my issue, but there was an immediate close event after Dosu responded. And then I'll go through one last one, and then we can go over how this actually works under the hood. But here, someone create an issue, they're trying to figure out what's going on. They have some logs describing their issue. And then with Dosu, users able to Dosu's able to help with the investigation, and then with the resources, the user is able to figure out that it's actually not a bug in Cosmos itself. So those are just a few examples of like what Dosu looks like in production. And then now that like we can peek under the hood into like what this actually looks like and how it's implemented. And like Stephen was saying, LLMs are an incredible piece of technology, but it's not magic. They're only as good as the information they have available to it, and either from a training perspective or available within like retrieval augmented generation, so like in context. And as I was saying before, open source projects and software is constantly changing. So it's nearly impossible for the training data of a model to be up to date because things are changing on like sometimes a minute or hourly basis within your code base. So we instead have to figure out how do we make sure that the information Dosu has access to is extremely relevant and easy for it to understand, and always up to date. And so what that ends up looking like is actually, a very typical ETL data intensive application pipeline, which is a perfect fit for a tool like Airflow, where we have all these data sources, GitHub, Slack, Jira, etc. We need to ingest that data on a regular basis. So, depending on the data source, it could be every 5 minutes, 15 hours a day. Load that into a kind of its raw form, and then do post-processing to what we call extract engineering knowledge. So going back to the previous slide about all the types of questions that people ask and rely on maintainers for, can we look for this information in all the available data sources? And so that's what we mean by extracting knowledge. And what that actually looks like is kind of like bulk inference over all this information using LLMs to actually structure all these different data sources into a similar format and try answer these questions preemptively, and store it all in what we call our knowledge store, which is then accessible to Dosu at inference time. So whenever users make a request, it's able to search across its knowledge store for related artifacts and then reason over it. And then all that information, kind of users' interactions that I was showing before, are saved in our database as like a thread with Dosu, and then we're able to continue to extract knowledge from that as well. So, was Dosu correct? What was the resolution? Who resolved that thread or GitHub issue? Save it in the knowledge store and then reuse that for the future. And then we're also able to use this kind of central knowledge store for metrics and KPIs. So can we understand like what percentage of tasks are resolved versus unresolved, or which percentage of those did Dosu have a part in helping resolve? What are other types of metrics that users might be interested in seeing? And right now, a lot of these metrics are internal, but we're really working to expose these back to our users so that people can see, get a better sense of the health of their project or engineering organization within Dosu.
That's really great, Devin. And I just want to congratulate you, by the way. Like 10 months to have assembled a list of projects like that is really impressive, and it's really gratifying for us as well to see our platform being used to power those important open source projects. Not to mention our own, which you demonstrated there. Actually got a couple of questions before we open it up to the audience to ask questions as well. My first one is, why did you, again, as I said, it's great to see our platform being used to support all these open source projects through your platform. Why did you pick Airflow in the first place?
It's a great question. I think, I come from traditional, I guess, AI, this recent wave of LLMs, things look very new and different, but I come from a traditional data ML background. And once you get into actually productionizing LLM applications, you end up at something that looks exactly what traditional machine learning does, where the only thing that matters is having high quality data available to your models. And previously, Airflow was the tool for the job that I always used for traditional ML, and it's the same exact pattern for kind of these newer LLM-based applications where we are regularly processing data to make that available to the model at inference time. And so Airflow was just has like a great ecosystem around it, and just helps simplify the scheduling piece of this pipeline.
Yeah, that makes a lot of sense. In the end, it's all about the data. And as you say, Airflow has sort of been proven in the ML world. It's a natural extension. I'm curious, we've certainly found, sort of in talking with our customers and with the community, that quality control is a really complex aspect of using LLMs. You touched on this a little bit, but can you just give us a little bit more detail about how you make sure that any tricks you can share with us about making sure the quality of your responses is maintained or even sort of improved as the data and the models and the embeddings and so on change and get iterated on?
It's a really good question, and I would say an unsolved problem. It's something we think a lot about. Response quality is really hard to measure. What is nice about our domain, specifically within GitHub, is that there is typically like some resolution to a thread, or an issue. Unlike a traditional chat app where a user chats back and forth and then disappears. Typically with a Jira ticket or a GitHub issue, it will be closed, and there's a reason for it to be closed. And so we try use that as a way to basically post-process these threads and see like, okay, this was the ultimate resolution here. Did Dosu's response contribute to it, or was aligned with the resolution? So in the case where one of the examples I showed where Dosu comments it and then the user immediately closes, like that's pretty high signal that actually this was a good response. Or the other case where Dosu commented but didn't get any interaction from the user, but then they created a PR with the same change as what Dosu suggested. Like that's also very high signal that like it was quote unquote a good response. And so there's a bit of post-processing that we do to try and understand response quality. I think another piece of it is not only understanding like if we're doing well, but also trying to understand like what types of things do we do well on or do poorly on. And I think on those there are techniques around trying to correlate either user feedback or other things to the types of inputs to the outputs. So can we figure out like what types of inputs are we really good at, what types of outputs or inputs are we not doing well at, and then figure out why. So it's a very iterative process. I think something that we're looking very excited about moving forward is really bringing maintainers or just users generally to the process of improving response quality. What we found is that people really want to help teach Dosu to improve response quality. And so how do we more directly allow users to almost you can think of it as like modify Dosu's knowledge in order to improve responses down the line.
Great, that's a really great answer. And it reminds me of a common theme that I've heard actually, which is that sure, within your dev cycles and you're pushing new code into production, you can implement sort of similarity metrics and sort of semi-automated measures of quality. And of course, there's feedback loops with thumbs up and thumbs down. But what I hear consistently is that the indirect measurements, which is does the user seem happy by the actions they take based on the response, in a more sort of business context, if you like, are the most meaningful, because they're more likely to measure the truth of the response and the quality of the response than something like a similarity metric that can be misled just by simple rephrasings or alternative answers that have not been known before. And of course, ultimately, what you care about is whether the user is happy. The booking application, the travel planning application that I mentioned, for them, the chief metric that they track is, does somebody actually book a trip once they've gone through the chat application that recommends planning options. So I think that sort of outcomes-oriented approach to measuring quality makes a lot of sense.
Yep. Yeah, I think outcomes are like probably the most reliable signal, and in general, like we're always trying to compute as many metrics as we can to just get a sense of like, are we able to quantify quality as well? What attributes of Dosu's responses are highly correlated with like, good responses or good sentiment, from users. So, a simple example would be like, maybe can we figure out that like, when Dosu includes like 5 bullet points in its responses, that people find them too long and like they're correlated with like negative feedback. And so then we can adjust prompts or models in order to, improve on and avoid those failure modes.
Yeah, I was going to ask you actually a little bit more detail about those metric and KPI DAGs. Again, you've got Airflow that's running on a regular basis to gather those statistics. So that's the sort of thing that you're talking about there?
Yes, yeah. So it's computing simple metrics in terms of like kind of features of a message, if you will. So like character count, kind of like things about it. Did we share? Was there code included? Did we use bullet points? How many sources did we cite? So there's like kind of raw metrics. And then there's also like this thread level post-processing around like, can we identify, is there a resolution? Were we part of the resolution? What sources were cited in order to resolve it as well? And so, yeah, like that information is really useful for us to evaluate Dosu, but we also want to expose that back to users. So you can have more information about like open issues for your project or for the projects that you depend on as well.
Yeah. So in short, I think it's very powerful, of course, for Airflow to manage all of that data pre-processing that you're doing there, but also the post-processing for model monitoring for both classical and Gen AI models, and then also just these usage metrics and quality metrics. It makes it so much easier to add new ones once you've got that infrastructure set up. One of those, of course, that you want to monitor is cost. It's another challenge that I've seen teams face. It's just the cost of using these services. Is this something that you've wrestled with? Any recommendations around that?
Yeah, definitely something we think a lot about as well. I don't think there is a silver bullet right now. LLMs, especially like the top quality models, are very expensive. I think a piece of that is like, right now cost is often correlated with like the number of input tokens. And so sometimes by doing kind of more work upfront around knowledge extraction, we can kind of reduce the cost at inference time, because we have things kind of already well formatted, and we have to do less kind of at inference time, like processing of code, for example, which helps reduce costs. Another thing that we're trying to I guess be better about is adjusting Dosu's behavior based off question complexity. Some questions can be answered as a kind of a traditional RAG application. So just fetch the relevant information, return a response. Other issues, especially that are like around bugs or features, require more agentic flows where they're multi-step. There's planning involved, task decomposition. So optimizing the path depending on the query as well. And then I think long term, looking forward, and I think something that Airflow is really well positioned to help with is what you were mentioning before, Stephen, around fine tuning. So fine tuning is definitely like the best way to optimize costs currently. And so as parts of the product, maybe it's like query classification, become really well structured and we have a lot of production data for, then we can fine tune smaller models, or it even doesn't have to be LLMs, it could be classical models or fine tuning embeddings to do some of those tasks instead of always relying on LLMs. Will help a ton with cost and speed.
Great. This is so helpful and interesting, Devin. One more, I'm being a bit greedy here, but this is just so interesting. What about data privacy? Obviously, there's always a risk, or often a risk in these types of applications of sharing data, say between customers or between projects. Is that an issue for you? Is that something you have to think about?
Yeah, it's something we have to think about. On the enterprise side, people are also like much more, sensitive to that information. With an open source, we have more flexibility, but generally, like when we do all of our data processing, we're partitioning and like by organization. So kind of your organization is processed in isolation relative to other organizations, and then also stored kind of partition logically by organization. So, actually, I think we model our pipeline a lot. We even use, in terms of like vector stores, we currently use LanceDB. And Lance, what is cool about it is that it is very similar to Parquet and like the traditional data engineering ecosystem. And so you can think of like data being partitioned in S3 based off an organization. So all the customers' data lives very separately in their own tables. Yeah, so I think that is kind of like how we think about data security and privacy. I think the more extreme examples, and maybe we will get there in the future, is like kind of having all open source models that everything is run within our cloud and like no data is leading to LLM providers. But right now we use a mixture of models. Yeah.
Great, thanks, Devin. And again, congratulations on your early success. It's great to see. So Ira, maybe again, I've been a little bit greedy. Let's see if there's any questions from the audience.
Sure. Yeah, I see some are coming. Maybe more will be arriving soon. So let me start with the first one. Can you share more around how Airflow orchestrates LLM consumption for batch workloads?
Yes, I hopped over that fairly quickly. Obviously, Devin has talked about that at least implicitly. One customer of ours at Astronomer also using Airflow for LLMs is Laurel. They're an organization that provides services for lawyers and accountants to summarize their activity for their clients. So essentially to help them provide end-of-day reports about what they've been working on so that they can bill appropriately. It's a very tedious manual process that they've substituted now with generative AI and large language models. And all of that is backed by constant model retraining using Airflow. And they just have massive quantities of batch inference applying those models to every single user action that their clients take through their lawyers and other professional services. So users take an action every few minutes and they have to assess that and they throw that through the model. Another one I've seen is processing customer reviews. It's sort of a good example just to illustrate the type of thing you do with that batch inference. Processing customer reviews and customer comments to get product insights. So you might have a feed of reviews coming in from Twitter, from social media, from Jira, what have you. And you want to use that to get a sense of what people are saying. It's a perfect use of LLMs, and you don't need anything fancy, just out-of-the-box models to summarize comments, identify which products they're talking about, do some sort of sentiment analysis, that sort of thing. So it's really just calling out to existing LLM services and applying that to an incoming feed of data. And you don't need to do it in real time. You just want to ingest the reviews from a variety of sources, pre-process the data, get rid of header info, formatting, and so on, and then apply the models one or more times in parallel. All the things that an orchestrator like Airflow it does really great and that Astro does at scale.
Excellent. Thank you. If there is any follow-up questions coming up, I will let you know. And the second one was, we currently use Azure ML for our MLOps, but are facing some challenges. What other frameworks are available there?
Well, Devin, I don't know if I have sort of like some philosophical thoughts about MLOps. In my mind, you know, there's no single platform, arguably, for doing MLOps, just as there's no single platform for doing DevOps, right? I mean, it's a combination of your source control and action scripts and your IDEs and the way you monitor feature launches and so on. It's a combination of many different tools and platforms that come together and have to be orchestrated together. And in the data world, that's the case. You're often using compute platforms like Databricks or Snowflake. You're running code in Python with different libraries that you're utilizing. You're maybe using Kubernetes for scale. A lot of things that have to be brought together in sequence with dependencies handled. And so, you know, you might argue that something like Azure is a platform for MLOps, or SageMaker or Databricks and so on, and they all, of course, play an important part. But I think they often exist alongside other things. And there are, of course, open source frameworks like MLflow that are arguably MLOps platforms, but I think they focus on a particular subsection of the entire end-to-end flow. So again, to me, it's sort of a collaboration between many different technologies. And of course, I will claim, though, that if there is something that brings all those things together, it is something like Airflow, which can coordinate them. And while Airflow itself doesn't do all of the machine learning, it's not going to train the models for you. It's going to orchestrate that by calling out to your Python code or by running your Databricks notebooks or by invoking the LLM. It's the thing that brings all the things together. But Devin, what are your thoughts on MLOps platforms?
Yeah, I mean, I would largely agree. I think there is no silver bullet. I think, like Stephen, you were saying at the beginning of the presentation, like pretty much all modern applications are data applications, and now with LLMs, like the ease of doing ML is like even the bar is much lower than it ever has been. So I think all modern applications are also ML applications now, and so like MLOps kind of just leads, you know, DevOps, MLOps, everything's kind of blurring into just like how do you build like reliable production grade applications. And in that, there's going to be you're going to use many different providers. I think, you know, generally, like it's nice to be able to buy into a tool that gives you as much of that as possible, but also gives flexibility because every organization is going to have some customization. So I think, yeah, like having something like Airflow for orchestration is able to like tie together different pieces is really nice. But yeah, I really think like there is nothing like you're going to use many different things, and it's just I guess you know how to figuring out how things work together is kind of the crux of the challenge.
Thank you both. We're coming to an end, but I have a couple of more. There was some questions. What are the best platforms to get in touch with you both? Where you're the most active?
Devin, I'll let you go first.
That is a good question. I would say Twitter. You know, I think we're as I said, we've only been around for just under a year, so we're still, I guess, building a community and growing our presence. I would say reach out on Twitter, either at my handle devsun64 or at dosu_AI. Also on LinkedIn, and then we have a if you go to the Dosu-AI GitHub project, we have a community discussion board. It's we're slowly becoming more active within that. So if you ever have feature requests or questions, you can go directly to the GitHub discussions in our GitHub org as well.
That's great. And I bet I know how you'll be monitoring those. For Astronomer, you can certainly go to the website and send us a message there on our contact page. You can also reach me on LinkedIn. And then I would also recommend taking a look at, we have a a trial version of Airflow running on the Astro platform that you can take a look at again on the website.